And here we are, seemingly finished with the gateways. We have walls, elements in the corners, the floor and the ceiling. But somehow the gateways need more details to create interesting visuals. But for what I have in mind, I need to combine the wall and the ceiling. So I need to somehow break the structure that I already created, with the walls out here and the ceilings down in their subnetwork. So let's get to it. With this poly extrude node, I gave the walls thickness. The node also conveniently offers to create groups for the individual pieces. The piece I'm interested in is the back, or in the context of the gateway, the inner wall. With that done, I can bring this into the ceiling subnetwork. Jump inside, make yourself some space, and in here create a null, connect it to the incoming walls, and create a blast node. For the blast, you can select the newly created extrude back group. Select delete none selected, and now we only have the inner wall of the gateway. Then take that right along to the next layer into the for each loop. Here do the same thing with the null, just to make it a bit easier to see where the walls are. And it is a good thing that we came back here. It looks like I made a little mistake here. Take a close look at the connection between the ceiling and the wall. When I created the bevel on the ceiling, I forgot that if I use the poly bevel on the complete ceiling, the bottom part changes its shape. But we can easily avoid this. Go to the node above and take a look at the point numbers. We only want to bevel the top of the ceiling. And as you can see here, the points that are relevant to us are 4 to 7. And now that we also changed the target group of the poly bevel, it only targets the selected points. With the idea I got, it might be good to increase the divisions up to 6, and then let's bring the distance up to the maximum amount before the beveled point would cross each other, and this should be enough. Now that the ceiling has a roughly round shape, the ceiling machine also fits better into it. But back to the main idea. I solved the first problem. I now have the wall combined with my ceiling. But in this ceiling subnetwork, I handle one gateway at a time. The wall group, however, includes all the gateways. We have multiple options to solve this. We could go back to the network where we created the IDs and make sure that all the ceilings also have the gateway ID. By doing that, we could easily use a blast node with the stamp. But the way this is set up, there's a quicker and easier way to do it. To place the ceiling machine, I got myself this point, a point that is in the center of each gateway. So I'm going to use that point to get rid of everything that we won't need for this current gateway. Let's head back over to our walls and create an attribute wrangle. This wrangle will go over each point of all the walls and use that center point to find the walls that belong to this gateway. And we only need to write one line of code for this. We need an if condition that takes the distance between the current point and the center point coming through the second input. And if that distance is higher than 10, it's fair to assume that it is a point from another gateway. So let's remove it. Now we have one ceiling and one wall. So let's combine them with a merge node. Now that I have a combined structure of the ceiling and the wall, I can transition over to the next phase. For that, I need a few random points on the structure and use it to copy boxes over it. Let's limit that amount to about 50. Then create a default box, use the copy to points up and connect them accordingly. So far so good, but we can't use the points like they are in the moment. For one, the boxes should be at a different scale each time, so we need a random value. That value we're going to use to feed into the p-scale attribute, an attribute used to define the size of certain elements. To get that random value, we just need to use the point number in the random function. For the look I'm going for, I need these boxes to ignore the point orientation. So I'm going to set the normal to 0. Then I need a lot of intersections between the single boxes. To get that with this amount of boxes, I increase the size drastically. You will get interesting looks if you play with the size of the box and the amount of the scattered points. But be aware that this can become performance heavy if you increase the point number too much. Because now we take the original geometry and create a Boolean node with the boxes. When set to seam, the Boolean node gives us the edges of both geometries. And if we limit that to only the AB seams, we get what I was looking for. These lines already have an interesting pattern, but with a simple trick we can build on that. Use a resample node to get more points, The default setting will do. And then create a carve node. It is used to carve out only a section of the given geometry. These will be the thicker pieces. To show that, let's create a polywire. And this is a bit much, so decrease the wire radius to about 0.01. Then I bring in the resampled lines once again and create another polywire. This one will be even smaller, so let's use 0.005. Let's merge them together and see what we get. Now the lines are so fine that it is not that easy to see the difference, so let's make it a bit more obvious by choosing different colors. Make the thick ones black, and later on I want to give the thin ones a material that emits light. To give you an example how this could look, let's set the color of the thin wire to maybe green. And that looks not too bad. Together with the sealing machine, this starts to get a sci-fi flavor. Bring down the rest of the geometry and the output now and connect this merge with the previous one. Let's jump out of the network and check if the operation worked on every gateway. And in fact, it did. And one little detail we can add, if we go back to the scatter node, there's a parameter called global seed. If we change that one according to the gateway ID, we can be sure that every time the boxes get distributed in a different way. And since we are in a for each subnetwork, we also still have the stamp. Just copy and paste that one into the global seed and you're done. Now we have a design for our gateways. Next follows the much bigger task, the design of the corridors. In this module, you learned how you can model your own grades. The methods shown can also be used for any kind of assets. You also saw how a for each loop can lay a trap for you when dealing with randomization. This is especially true for the old for each subnetworks. So this also makes it a good point to switch over to the newer for each subs. And last but not least, you saw how you can make adjustments to your design. Houdini gives you the possibility to use each and every part of your geometry wherever you need it, so make use of that.